graph using slope-intercept form. So this is for lesson 4.5, and it starts on page 244 if you're following along in the textbook. And this is the thing I've been going over in class that I keep on referring to, which is y equals mx plus b. Okay, and we're going to get into what all that means in just a second. It's actually listed right here. The slope-intercept form, if you remember, we talked about how sometimes slope, which we learned about last lesson, can be represented as m. And that's just the ratio in the change in y over the change in x between 2 points. And this right here is going to be actually the y-intercept. So if you look at the example here, and it might be easier to see in the textbook if you're following along, then this line here is actually y is equal to 1/3 x plus 1. Because if you see, it crosses right there crosses the y-axis at 1. That's the reason why it's right here. But if you look, so it crosses right there at 1, and the slope is going to be 1/3 because it goes up 1 over 3, up 1 over 3, and so on. That's how it works in terms of the slope-intercept form. So let's get going on this as a couple of examples. So it says here, for example 1, identify slope and y-intercept. This one here is, if you got those definitions right there, well, the slope of problem A is just the thing. If it's in this form, y is equal to 3x plus 4, all you have to do is, well, the slope is right there, 3. The y-intercept is right there, 4. Pretty easy, huh? Now, sometimes you have to rearrange things, and that's what's in this part here. 3x plus y is equal to 2. Then you have to rearrange it, so you have to subtract 3x from both sides. And when we do this, it is important to realize, well, that's going to be y is equal to 2. Actually, it's going to be positive 2 minus 3x. And we can't leave it like that because it has to be plus, it has to be y equals mx plus b, not b minus m. I suppose you could figure it out that way, but I prefer to do it this way. Y is equal to, this is the same as negative 3x plus 2. And then it's nice and easy to identify. Negative 3 is the slope, and 2 is going to be the y-intercept. So that's how it works. Let's do a couple more. This problem here says here y is equal to 5x minus 3. Check it out, nice and easy. Slope, and negative 3 is the y-intercept. I know that one's there is pretty easy. So 3x minus 3y is equal to 12. This one's a little bit harder because we're not looking for 3y or anything like that. We're looking for y by itself. So we're going to subtract 3x from both sides. Then we end up with negative 3y is equal to 12 minus 3x. We'll do switching that around in a second. Now we've got to divide both sides by 3. When we do that, we end up with negative 3 actually. So when we do that, we end up with y is equal to, well, negative 4, because 12 divided by negative 3 is negative 4. And then this is going to be plus 1x, because it's kind of like dividing negative 3 by negative 3. And then we can rewrite this, y is equal to x minus 4, or plus negative 4 if you prefer. Our slope, there's nothing in front there. That means that the slope is 1, because we don't put 1s in front of variables because it's just assumed to be 1. So this is 1 over 1. Each time you go over 1, you go up 1. And here is going to be the actual y-intercept. So let's do this last one here. So x is equal to, oh wait, actually, let me correct that. It doesn't say x is equal to, it says x plus 4y is equal to 6. So So we need to get the y by itself all on one side, so we're going to subtract x from both sides, so we end up with 4y is equal to 6 minus x. Divide both sides by 4. We end up with y is equal to 6 divided by 4 minus x divided by 4. So now let's switch this around. Y is equal to negative x divided by 4 plus 6 divided by 4. And we can simplify that even more and make it a little bit easier to read. This is the same as negative 1/4 times x plus 3/2. If we want to do it that way, that's fine. So that's going to be our answer. Now we've gotten the right formula. So the slope is going to be negative 1/4, and the y-intercept is going to be 3/2. So now we're moving on to how we graph these equations. It's the same way as before. We're graphing equations. If you are asked to move this into slope-intercept form, well, in this case here, it doesn't say you have to do that, but in my opinion, it's easier. 2x plus y is equal to 3. If you wanted to, you could do the x-intercept, y-intercept thing. But in this case here, we're working with the slope-intercept form, so we're going to change it around. So when I change this, it's going to be 2x plus y is equal to 3. So it's going to be y, subtract 2x from both sides, 3 minus 2x. So y is equal to negative 2x plus 3. Just switch those around. So the slope is going to be negative 2, and the y-intercept is going to be there. So I can plot that first point, which is right there, 0, 3, because if I plug in the value 0 for x, then y's value is going to be 3. That's why it's the y-intercept. And now I just come up with a couple more points. If I want to plug in the value for when x is equal to 1, it's going to be negative 2 times 1 plus 3 is equal to, well, because again, I'm going to just go write this over here. The first point is going to be x, or 0, 3. That's the first point. That's the y-intercept. So now I'm coming back to this. If x is equal to 1, so it's going to be negative 2 plus 3. Negative 2 plus 3 is going to be positive 1. So the next point is going to be 1, 1. And then the third point, as I always say, you need to do at least 3. If I choose the point to be 2 for the x plus 3, that's not going to be negative 4 plus 3, which is going to be equal to negative 1. So then it's going to be 2, negative 1. And one way of checking this is if you graph it, you can say, okay, well, you know what? Because I know the slope is this, I know I'm going to go down 2 for every one I go over. So down 2 over 1, down 2 over 1. And so if you look, that actually works here. Down 2 over 1. And the same thing here. Down 2 over 1. So that's one way of thinking about it. So what they have here with this part is writing out an equation. To get to one floor, from one floor to another at the library, you can take either the stairs or the escalators. You can climb the stairs at a rate of 1.75 feet per second. The escalator rises at a rate of 2 feet per second. Apparently you're moving pretty slowly. I know I can beat the escalator up the stairs. You have to travel a vertical distance of 28 feet. The equations model after the distance you have the equations model after the vertical distance d in feet you have left to travel after t seconds. So this here is going to be the equation here. So it's going to be the distance you have is equal to negative 1.75. 1.75 is that's the amount that you are traveling in feet going up the stairs each time. So that's times t plus 28. So you start off 28 feet distance, and then you're going up a bit at a time. So each time this variable changes, you get a little bit closer. So for each second, you're a little bit closer to the top. So same thing, the other equation here, it's d is equal to negative 2 because you're traveling 2 feet times t plus 28. Here you're traveling 2 feet per second. And so it's the same idea. And then if you wanted to draw the slope, you can graph these things. Plot the y-intercept, in this case here. Well, the y-intercept is going to be 28 in both these. So that's why they still have the same point right there. But the slope is going to be different. The slope in this one is 1.75, or negative 1.75. The slope in this one is negative 2. So what you could do is you could just plot the points. You could use the slope-intercept, or excuse me, the x and y-intercept thing, and figure out where they're going to cross. Or you could plug in values for here. Like if I plugged in the value of, oh, I don't know, let's say for 2 seconds here. For that first one, the distance is equal to negative 1.75 times 2 plus 28. So that's going to be distance is equal to negative 3.5 plus 28. So then it's going to be distance is equal to negative 24.5. Or not negative 24.5, positive 24.5, because I'm subtracting 3.5 from the 28. So that's going to be my point when the value is 2. So if I want to plot that point, it would be 2 and then 24.5. If I wanted to do that, I could. Same thing with the other one. If I have here another value, d is equal to negative 2t, this one's a little bit easier, plus 28. And then I plug in 2 for the value of t. It's going to be negative 2 times 2, that's negative 4, so it's going to be equal to negative 4 plus 28. It's going to be equal to 24. So that other value is going to be 2, 24. So I could plot those and then see the way it would work. Same thing down here, it's just graphing. Remember here, y equals negative 2x plus 5. Always go ahead and graph your y-intercept first, because you know when x is 0, y is going to be equal to 5, because that's what's over here. So that's the first point you should always plot. So that's 0, 5. Then start plugging in numbers. If x's value is 1, then it's going to be y is equal to negative 2 times 1 plus 5. So that's going to be equal to negative 2 times 1 is negative 2 plus 5, it's going to be 3. So the second point is going to be 1, 3. Third point, we would do y is equal to negative 2 times 2 plus 5. Negative 2 times 2 is going to be negative 4. Negative 4 plus 5 is going to be 1. So our third point is going to be negative 2, 1, or excuse me, just 2, 1, because that's what's in there. So those are 3 points, and if we plot them right, that should work. And very importantly, if we plot them right, it will be a straight line. So here, they're talking about commercials, and it says here, a company produces 2 30-second commercials, one for $300,000, the second for $400,000. So that means that that's the amount it costs to create the commercial. Each airing of the commercial on a particular station costs $150,000. The cost C in thousands of dollars to produce the first commercial and air it n times is given by C is equal to 150 times n plus 300, because 300 is the amount it would cost to make it, and then 150 is the cost each time you air it. So n is going to be the amount of times you air it. The cost of the second one is 150. C is equal to 150 times n plus 400. So then it's graphing both equations on the same coordinate plane. And what you're going to do is you're going to notice here the slope is the same. So you end up with 2 parallel lines. They just start off at different points, because the thing that's different is the y-intercept. So 400 and 300 is where they're going to cross. And they will always stay in equal distance apart. They're always going to stay about 100. Well, they're going to stay exactly $100,000 apart, because that was the cost of creating the commercial, the distance or the difference between them. So if you were to graph them, you would just do what we did before, and then looking at it, it says here, based on the graphs, what is the difference of the cost to produce each commercial and air it 2 times, 4 times. So basically, the difference is always going to be $100,000. Those are 2 parallel lines because the slopes are the same. Same thing down here, it's just talking about if two lines are parallel, they have the same slope. They don't intersect, no matter how large you make the graph. And they have an example of it here. So here, you have points, and you're figuring out the slope based on the points. So for the first set of points, that's what these are here. The slope is going to be 1/3. The second set of points, because it's 5, 1, and 0, -3, the slope is going to end up being equal to 2/5. So those are not parallel. So let's figure out, so I can get rid of this one. I'm going to get rid of this one. So this is the next point, and I'll do the slope for that too. So in this case here, it's going to be 2/6, which actually, if you simplify, is into 1/3. So this one here, and so this line and then this line are actually parallel because they have the same slope.